my talk is Dash, or Interactive Data Visualization Web Apps Without Using JavaScript. And so an alternative kind of title for this talk would be kind of really what you can, can't, should, and also probably shouldn't do with Dash, which is a project by Plotly. And so for the remainder of this talk, I'm going to kind of go over a couple of different areas, and first off explore why it is that you might want to use Dash. And then, I'm sorry, I'm just making this slightly bigger on my screen. Explore why it is that you might want to use Dash, and then kind of give a brief introduction to how Dash works and what kind of things you can do with it. And then a couple of the lessons that we've learned from my company, decisionLab, about what you might, things that you might want to think about as a Dash app grows or as you incorporate Dash into your team. But yeah, please do shout out with any questions if you've got them, or feel free to approach me later on if this is an area that particularly interests you. So, just before we go on, I should offer a brief kind of disclaimer. I'm not an expert necessarily on Dash, and this talk is really about using Dash at work. I'm not an author on the project, and I really hope one day I will bump into someone who is an author on the project. And so if anything is incorrect or a little bit out of date here, please do kind of let me know. And so there is another question really, which is why am I here in the first place? I mean, more to the point as well, I'm a full stack developer by trade, and it seems a bit strange then that I would be using JavaScript, or using Python to write my JavaScript. I'm a perfectly comfortable JavaScript developer, so why am I using this kind of obscure Python library in order to make interactive web pages? The main reason is that I work for, as I said, these guys, decisionLab. We are a mathematical modelling consultancy based in central London. And just on that point about being in central London, if you are following the latest with the whole Brexit debacle, I'm really terribly sorry. It's quite embarrassing these days, and I have no idea what's going on either. And in fact, actually, I think it's just worth saying it's actually my third European PyCon in as many weeks. And actually, I really do love the kind of Python and open source community. I think it's brilliant when we have so many people from different nationalities and backgrounds all coming together for technology. So more of this, less of that kind of Brexit nonsense, please. So moving on. As I said, decisionLab, we're a mathematical modelling consultancy. Our expertise are in machine learning, optimization, and simulation. We work primarily in sort of defense, engineering, intelligence, and a few other kind of public body kind of organizations. And our main kind of selling point is that we enjoy interesting and unusual problems in data sets. We also, rather than just writing reports for our clients, we tend to build tools and products that solve particular problems. We don't just kind of settle with writing a single piece of data analysis. We want to make a tool that is useful for kind of ongoing analysis. And some recent examples of some projects that we've done are, you can see here, we developed a system to detect illegal gold mining in the Colombian Amazonian rainforest using machine learning with human in the loop. And at the moment, we're also developing a predictive maintenance service for the Type 45 Royal Navy destroyer. And so, yeah, you can kind of forget AWS, forget Azure. Our deployment environment is currently a warship, so it presents some interesting kind of problems. So we're a company of data scientists and a smaller team of software engineers as well. And one of the things that we kind of notice in our team, or that we kind of come up against sometimes, is that there is, in a sense, two cultures to Python. And it's kind of got the sort of the data science sort of culture and background, or PyData, and also the kind of software engineering side of Python, the SQL alchemy and sort of, the kind of database and web side. And it's not quite, as such a gulf as the classic two cultures debate that you might have from C.P. Snow in the late 1950s and so on. But these kind of two, broadly speaking, two kind of backgrounds of people who come to Python is kind of significant. And these people have different priorities and different sorts of approaches. And collaboration, obviously, between these kind of two groups is absolutely key. But that can also be costly sometimes on small projects. If you want someone who maybe has just finished their kind of PhD in a data science related field to suddenly become a software engineer, that takes time and that's expensive. And so my team, we kind of bridge that gap with the production team, and we aim to take our tools from data scientists and turn them into products. But when we're developing alphas or proof of concepts, we really want to be able to kind of empower a data scientist and minimize the new technologies that someone who might have just finished a PhD or whose background is in, say, simulation modeling, minimize those kind of new technologies that they need to learn or start to use in order to be able to build something effective and useful for us. And so exactly, I want my data scientist to take a lead prototyping a proof of concept dashboard. And obviously there, if we're developing a website or a proof of concept dashboard, their background's not going to be in web development. And so we found this tool by Plotly called Dash. It's an open source product. There are some paid consultancy options. I think you can sponsor a developer and so on. And it's quite a young project. It recently hit version 1 in June, and it does kind of change quite rapidly. And so the unique sort of selling point of the tool is that you can build an interactive website without having to use JavaScript. And that's mostly a good thing. Sometimes, not always, and we'll kind of explore that in the rest of this talk. So, as I say, we'll go over a little example of how Dash works, explain some of the things that you can do with Dash really quickly, and some of those sort of tips and perhaps good practices that we've started to learn and some of the things that we're trying to take forward. And then kind of give a sort of an opinion about when you probably need to stop using Dash and actually start building a full-scale web application. There are some code examples in this talk, and you can see all of them at this GitHub repository there. I'll put them up a few more times, and I'll tweet it out later on and so on. So, first things first, dead simple to install, just pip install Dash, and then you can start running your applications. I ran out of time just before this talk, but I am convinced that you can actually write a one-line Dash app based on the brilliant lightning talk that we had last night, so I'll figure that out. So, as a brief Hello World example, here it is. So, just to kind of talk this through, we've got two libraries here that we have to import, Dash and Dash HTML components, and I'll come to exactly what they do in a minute. We create our application, and if you're maybe familiar with Flask, it's exactly the same. In fact, under the hood here, Dash is creating a Flask application for you, and you can supply or inject your own Flask application if you want to do something a bit more advanced. Here we define a layout, and we've got a very simple layout here with just a single div tag or a division, and inside there we've got a header tag or heading 1. And then you can see down here we're just literally running our application. So he bravely loads up the live code example. And so here you can see this is the GitHub repository that we've got, and now we've just got a very basic kind of hello world example running on my laptop locally, and there's no need at all here to kind of use any JavaScript to create a single web application. I've cheated a little bit and put my logo up at the top, and that's because you're able to inject a style without having to actually kind of declare it in the application. It will look for that automatically. And I've also, in that GitHub repository, there's a Docker Compose file there. So if you just run that Docker Compose, it will run all of these different applications at the same time on various different ports. So you can have a play around with them. So, sorry, this is never quite as slick as you'd like. But here we go. We'll come back to that in a sec. So, so that's great. But and so let's kind of discuss what's happening under the hood here internally. So as I said before, there are two packages that are being used internally by Dash here. The first one is Dash HTML components, and that's really just a wrapper around a ton of React components. So Dash have created a set of what they call Dash components, which are kind of Python callables that you can use to create a web layout. Under the hood, it just wraps all of these different React components, which themselves wrap or kind of create HTML components based on the HTML schema. There's also this other package, Dash, which manages the relationships between all of these different components, and it serves the application using the Flask instance locally for you. But the title of this talk is to do with interactive web pages, and so we want to have an interactive Dash application rather than just sort of a hello world. And so the first application that we'll build, I'm going to call it like a hello anyone kind of application. And broadly speaking, what it's going to do is this. So we're just going to say hello to someone, but we're going to take their name using a text box. So before we discuss how to do that in Dash, let's have a quick look at how that works in plain old JavaScript. And so first off, we're going to need some HTML. And so to make this work, we're going to have 3 DOM nodes. And if you're wondering why they're called DOM nodes, it's not because I'm called Dom and I'm really vain. It's because there's the document object model, which is kind of a fundamental part of web development. I just happen to be a web developer called Dom, which is useful sometimes. So these 3 DOM nodes, let's have a look at them in a kind of a tree representation here. We've got the paragraph, which is going to contain our text. We've got a span inside of that paragraph, and so that'll contain the name of the person that we're going to greet. And then we've also got an input here, also this will be like a text box, and so we're giving the span and the input IDs, which are kind of denoted by that hashtag there. And so our application, or our JavaScript application, is going to take the value from that input, hello input, and it's going to set the HTML inside of our span to be the value from that particular input. But crucially, rather than just doing that once and then forgetting about it, it's going to have to monitor it continually, because this is a JavaScript application in a web browser. So whenever, if a user decides to change their name, or as they're typing and each particular key press that they make, we're going to have to update it every single time that happens. And so ordinarily, with the JavaScript application, the technologies at work here are JavaScript and React. Now, JavaScript is a programming language. It runs in the browser and allows you to alter the DOM and kind of manipulate it to do whatever you want. And then there's also React. And React is the library that means that rather than having to write complex JavaScript applications to continually monitor things or constantly access different parts of the DOM, we can just declare, using a kind of a declarative interface, declare what sort of changes we want to happen, and then React will sort the rest out for us. And so in a standard plain old JavaScript application or plain old React application, we'll have essentially a function that looks something a bit like this, which is going to interpolate our string for us. So it's going to take the value from that particular text box, and then it's going to put it inside of our span. And so in React, that code that kind of defines what we want to happen lives inside the browser. It's a JavaScript function that's going to be executed inside the browser on the user's computer. However, in Dash, all of these kind of interactions between different parts of the DOM are handled by what we call callbacks. And these are Python functions which live on the server instead. And so whenever their inputs change, which we'll come to in a sec, they're executed on our server. And so that means that we have to cross a network now, go from our browser to our server and then back again every time that we have some kind of interactive change or thing happen inside of our application. So let's have a look at what this particular app would look like inside of Dash. And so you can see here again, we're defining our layout up at the top here. And this time we've got our heading, just like we had before. We've got our input as well, which is going to be the kind of text box that takes the user's name. And here we define this particular callback. So what we're saying here, you can see that this is their decorator at work. And so we're saying, in this particular callback, whenever the value inside of our input changes, and so that's the input here to this callback, we want to run this piece of code, which is going to interpolate our string for us. And then we want to send the output of this particular callback and put it or set it as the value inside of that particular span, inside of this heading that's working up at the top here. And so this means that essentially Dash is going to create a React application for us, and then whenever that React application notices that something inside of that text box changed, it's going to go to the server, say, hey, what do I do now? And the server's going to say, oh, update the heading to give the user this particular value from our function. So it's a bit like Excel, really. And so whenever you say, oh, this particular cell is going to be the input, or it's going to be this cell multiplied by this cell, Excel will work out the relationships between the different cells and sort of call all the functions as required. So this means that now every single change that happens inside of our web application needs to run a Python function which lives on the server. And this really does cause like a very large performance loss. JavaScript and React in particular is lightning fast, and it has a very, very cool kind of string diffing algorithm called Fiber, which is one of the reasons why it's such a popular tool. Whereas now we're constantly crossing a network rather than kind of exploiting the benefits of JavaScript inside of a browser. So there's a big performance loss there, But that's actually okay. It's not something I've ever had to really worry about. I want to empower a data scientist to build an app really, really quickly using familiar technologies in order to get to a proof of concept or kind of an alpha phase. I'm not really worried about production workloads or whether or not it's going to crash if we have hundreds of users or if it's possibly a little bit laggy sometimes, because it's a specialist web application. It's for data science purposes, and it has a very specialist audience. So, admitting that we're going to maybe take a hit on performance, but we're going to allow our data scientists to go really far without having to hand over work to software engineers. Let's have a look at some of the things that you can do in Dash really, really easily or really quickly. So as the name kind of suggests, it's mostly geared towards dashboards, and there are other tools as well that do that kind of thing, like panel or bokeh and so on. But the real kind of selling point of Dash is that you can also do quite what we call transactional things really, really easily as well. So let's have a look at some other very quick examples, and these are all in that GitHub repository, which you can see the URL for there. So I'm going to list a data set here, which is the kind of Titanic passengers data set. So it's just a couple of hundred rows. Then I'm going to display a graph. I'm also going to make a transactional request to show what I mean about why Dash is really so powerful. So first example first, the Titanic passenger data set. So again, here we're defining a layout that we're going to use, and the first kind of the main component that we're using here is something we've imported called a dash table. And this is basically just going to display our data frame for us with pagination if we need it, and it's going to put columns and so on and so forth in. And then we've also got this drop down here, and so I've decided that rather than just display the data set, I'm going to allow a user to filter based on a particular category. And so that will be done by a callback that we're defining here. And so we're saying, we're monitoring that particular drop down, and then we're going to alter the data that gets sent to that dash table as a result. And here we're just literally filtering based on sex, and you can see it's just a really standard kind of pandas filter there. And so, I'm sorry, I didn't realise I didn't show some of our examples before. Let's start. So just to kind of show some of the examples of what we have here and actually prove that this works. So here we've got the very basic example that we had before. So we can say hello PyCon, and you can see we've got an interactive web application there, absolutely no JavaScript involved. Now if we come to our slightly more involved, sorry, I should have shown that to you before, I'm terribly sorry. So now if we come to our more involved example with the Titanic data set, you can see here I've just listed, and this is running live on my laptop at the moment. I've just loaded a data set used from literally pd.readcsv, fed it to my dash table using that particular callback, and you can see now, so at the moment I'm showing all passengers. If I decided just to show the female passengers, it's just updated that for me there, and then it's going to constantly monitor that for me as well. And you can see this is a really super basic example, but with a couple of those callbacks kind of combined together, some other interfaces and a bit of thought, you can actually make really quite advanced applications here without ever touching any kind of client-side code. So next thing we want to do is display a graph. And so this is a project by Plotly, who are obviously quite famous for their graphing tools. And so it's no surprise that actually the graphing tools that we get from built in essentially to Dash are really quite strong and quite powerful. So here we're defining a layout. This is the second example. We've got, you can see here, it looks like a lot of code, but that's just because it's formatted with black. But you can see there's this component here from Dash core components, which is just a very simple, straightforward graph. It has an interface which is quite similar to a standard kind of Plotly graph that you might use in a Jupyter notebook or something like that. And here at the top, you can see I've just provided it with a very basic data set based on the Titanic passengers. And so this is the letters of the alphabet and the frequency with which passengers on the Titanic had a first name beginning with that letter. So I've split up, or I've counted the passengers on the Titanic by the first letter of their first name. And also, because this is for a bit of fun, I decided to do it in one line because I always find that more fun than coding things to be readable. So have a little look in the repository there. Apologies, I'm sure there's a more efficient way to do that, even in one line. So just to demonstrate what that looks like now. So you can see here on the next example, we've produced a very basic sort of histogram here. And so you can see that I think the most common letter was J for a passenger to have. And so here we've created a web application that's displaying data in a chart on a user's browser with no JavaScript involved whatsoever. And you could use, say, a callback here to filter by sex, like I did on the dash table example, or you could use any other kind of combination of different dash tools together to make something more involved and more impressive. So there we go. The next thing I want to demonstrate is a kind of a transactional web application. And so this is a kind of a classic web development example here, making a to-do application. And so this is very, very basic. We're just going to basically take some input from a user, store it somewhere, and then kind of display it as a list of tasks. And so to do that, you can see here we've got an unordered list. So I've created this dash layout here. There's a heading at the top, an unordered list that is going to list all of the different tasks that I have in my data store somewhere. We've got an input, and then we've also, which is going to take the text for a new task, and then we've also got a button. And so that button is just going to be the equivalent of our submit for a form. And so here I've created a really basic data store, which in this case is just a dictionary in memory, but there's no reason why that couldn't, say, be MongoDB or Postgres or call an API or do some other kind of magic. And here it's a very basic function which is going to return each particular task from my data store wrapped in this dash component, which is a list item. And so here this, again, might look like a lot of code, but it's really all stuff that we've gone through before. We've got this decorator, and so here we're going to say that whenever this particular button is called, or whenever this button's clicked, i.e. the number of times it's clicked increases by 1, we're going to send something to our unordered list. So that's basically where our tasks are being displayed. And here this state option means that whenever the button's clicked, I want to get the value from my input, so from my text box, but I don't want to call this particular function every time that text box changes. So I'm just getting the state of the text box rather than monitoring it for changes. And so here, literally what I'm doing is appending it to a particular list inside of that dictionary. And then you can see the results. So kind of an example we've got here, we could do something like milk, and say do something else. Okay. And you can see now this persists as well when I refresh the page because it's stored in my my memory on my computer. But you could obviously put that inside of a database or do something else. And that ability to actually change data and kind of persist it, I think, is really quite powerful and one of the things that makes Dash so good, really. And you can see some of the reasons why in an example I'll show you in a minute. So yeah, you can use that particular functionality in Dash to go really, really far. And so an example of something recently was the gold mining project that I mentioned earlier. We were able to build a very basic, this is actually a couple of versions behind where it is at the moment, but a very basic interactive web application for use by Colombian law enforcement. And this isn't really like super slick. It, it's not, doesn't look like Airbnb or something like that has a huge front-end team. But it was built by one junior and one kind of middle mid-career sort of data scientists over the course of a couple of months, and that was as they were doing machine learning and model training and so on. This wasn't built by software engineers or kind of handed over to a big UI team. It was literally built by the data scientists who were kind of liaising and working with people on the project. And here you can see we're able to use human-in-the-loop machine learning using Dash because we can take inputs from a user and then store values inside of our database which inform our model, which is used to take our satellite imagery. And so we're not just displaying data here, we're actually able to kind of manipulate it and alter it using Dash and using the dashboarding tool. So at decisionLab, we've taken Dash quite far, and we've started to build much like larger Dash applications, and really started to take it as far as we possibly can, because it's such a useful tool to accelerate some of our development. And so some of the standard tips for any larger project, the main thing you need to do in a Dash application is organize your code, and that partly comes down to the sort of the two cultures of Python that I mentioned before, because some of these tips about splitting up, say, callbacks from layouts, or giving individual features their own sort of functions and directories and so on, and abstracting that kind of logic isn't necessarily something that isn't necessarily something that comes immediately to someone who might have a background working in data science and do Python notebooks, say. So a standard kind of layout that we might have here would just be we run the script as a module using a done domain, and then we have callbacks and layouts split up, and that's separate from our app as well. One thing, a project that we're also working on at the moment, is to take some of the code that we have to sort of manage building applications in Dash and build a sort of pseudo framework using it. So at the moment we've actually created a sort of mini framework internally that uses a decorator syntax in order to define layouts and define callbacks, and then brings them all together at runtime and actually builds an application that implements things like routing and navigation. And so if this is something that you might be interested in, and as we're looking to open source this project, please do get in touch. We've had a bit of interest from a couple of other people as well, so it'd be nice to get a little mini team going on that. Just kind of brings me now to my sort of final few points about when to stop using Dash and actually to start building what we might call a proper web application. And so you've kind of got to think about what Dash is good for. And so, as I said here, one of the brilliant things about Dash is that it allows for really rapid UI development by people who aren't specialists in that field. A data scientist can develop a full UI straight away, really, without having to become an expert in JavaScript or other associated technologies on the web like CSS and so on. And it really allows for informed web development as well. Your user interface can actually be built by people who know their stuff on machine learning and know the problem that they're building a tool for really inside out. And they don't have to hand over work necessarily to a software engineer or a JavaScript developer who doesn't necessarily live in that world or have that interest. But also presents problems for exactly the same reasons. So, for example, that rapid UI development that you benefit from so much towards the start of a project, if you know you're going to be developing a much bigger tool, are you going to be creating technical debt straight away? Do you need to employ a JavaScript developer or get one on your team really from the get-go? And that idea that this is UI development is also informed, well, informed by whom? Data scientists? Yeah, that's great, but they're not users. Do you need to get a user researcher in, or actually employ a UX consultant to start thinking how we're going to build a good app rather than just an app? So Dash is really brilliant for facilitating that kind of rapid development of data-driven interfaces and dashboards. Investing a little bit of time into Dash and organizing your code properly allows you to go really, really far inside of a Dash application. But reassuringly, front-end developers will still have a job, so this is not going to replace JavaScript. So yeah, thank you very much for listening. Oh, damn, I thought I'd got rid of all the references to Berlin, but there's one in the end, sorry. Yeah. Cool. Have we got... Yeah, time for a question at all? Or? No, we're good. Oh. Yeah. No, so yeah, definitely go ahead.
I'm just wondering, for visualization, that makes sense. Can you also use it to write back to the data frame or database?
Yes, yeah, you can. So, the question was, you can use Dash for visualization, but can you also use it to sort of write back and persist changes, perhaps server side? And yes, you can. So, for example, on the gold mining app that we had there. So we were using human-in-the-loop machine learning, and we were actually taking the sort of accept reject from a Dash application and storing it on our server. And the to-do application example, for example, here, very quickly. So these tasks now are stored inside of my computer's memory, and there's no reason why I couldn't necessarily persist that to a database inside of my callback, or make an API call or something. So when I refresh the page here, they come back, and I could add something else in, and that's now stored on my server. So yeah, you can. Yeah, brilliant. Thank you. Yeah, thanks.